Let's start. It says a sports director at a school analyzed data to determine how many learners play sports and what the gender of each learner is. The data is represented as follows, okay? So you have males and you have females, and then you have those who do not play sports, and you have those who play sports, and then you have the total, eh? So this plus this gives me that, so that's a total. Then this plus that gives me that. Then this plus this gives me that total over there. Then this plus this gives me that total over there. And then this total plus this total gives me that total. And so forth, eh? Okay, so what's the questions? 9.1.1 says, determine the probability that a learner selected at random is male. So what is the probability that a learner is a male? So let's write 9.1.1 down. So the probability of a learner being male is, I'm going to go to male and look for the total number of males. So there, if you look there, there is the total number of males. So I'll take the total number of males over the total number of learners, which is that number over there. And that is the probability that a learner is male, 0.51. 9.1.2 says, what is the probability that a learner is female and plays sport? Okay, so the and means it's one number in the contingency table, eh? And is one number. So let's go look for female and play sports. So here's female. So it's definitely in this line over there. So that line. So it's either this one, but that's female and do not play sports. This is female and play sports. Okay. So there's play sports and there's female. And there you find this number 67. So now I'm going to say this is 67 over the total number of learners. And as a decimal, that is 0.28. Okay, so both of these, 2 marks for that, 2 marks for that question. Okay, our next question, 9.2 says, are the events male and does not play sport mutually exclusive? Use the values in your table to justify your answer. So for events to be mutually exclusive, the probability of the one event and the probability of the second event, it must give you 0. Okay, so event A, let's say event A is being male. So let's call this male. And event B is does not play sport. So not play sport. Okay, so the and means it's one number in the table, eh? So I'm going to go to male. So here's male. And I'm going to look for does not play sport. So it's definitely this number over here. So the probability of being male and not playing sport is 51 over the total number of learners. And this is definitely not equal to 0. So because it's not equal to 0, we can say therefore the events are not mutually exclusive. And that's how you would do that question, and that is for 2 marks, eh? So for working out this, and if you write that as a decimal, it is 0.22. Okay, next question. Our next question is, are the events male and does not play sports? Are they independent events? Okay, so for events to be independent, P of A times P of B should be exactly equal to PA and B. Okay, now remember, A is now being male, eh? So this is probability of being male. And this is the probability of not playing sports. So no sports. Okay, so we have to see that the left-hand side, this answer, we have to check that that is the same as this answer over here. So remember, this is male and no sports. Okay, so didn't we work out this right-hand side in the previous question? Male and no sports. So male and no sports, male and does not play sports, We worked that out. So the answer was 0,22. Do you remember? We worked that out. So now we just have to check the left-hand side. So we have to do the probability of A. So that is the probability of being male. The probability of being male, we worked out. There it is. The probability of being male is 120 over 236. And the probability of B is not playing sports. So does not play sports. So years does not play sports. It's 100 over the total number of learners. So it's this over that. And now I'm going to just say this times this and see what that answer is. So what is this times this? And I get that answer to be 0,22. So can you see that the right-hand side is the same as the left-hand side? And because the answers are the same, therefore, the events are independent. And that's how you would do that question. Our next question is question 10. So question 10 says, a survey regarding the most read magazines was conducted among 84 high school girls. Okay, 3 magazines, namely Glamour, so that's a magazine. Then we have Drum and we have Teen Vogue were used for the survey. And then they give you all the information here. I'm not going to read through it. So here they give us a Venn diagram. This is Teen Vogue, this is Glamour, and this is Drum magazine. So let's go look at the questions. 10.1 says, write down the value of C. So this C over here will be the total number of learners who's not reading any magazine. So let's go read our information. So here they say 41 reads Teen Vogue, 34 reads that, 40 reads that, 18 Teen Vogue and Drum. 8 read all 3 magazines, okay. 75 learners read at least 1 magazine. So this is important. So I have 84 learners in total. 75 reads at least 1 magazine. So these 9, they don't read magazines. So that means the C outside here is 9. Okay, then 10.2 says express F in terms of X. So okay, let's look. Express F, there's F, in terms of X. So F is in this circle over here. This is Teen Vogue, so in this circle. Now in that circle, we see 4 numbers. It's this one, plus that one, plus that one, plus that one. We know this whole circle, the whole Teen Vogue, must give me 41 learners. So I'm going to write that down. So X plus F plus 10 plus 8. Those 4 numbers, they will give me 41. Okay, let's write. This is 10.2. So now they want me to express F in terms of X. That means express F, leave F on one side and take everything else over. So I will have 41 minus X minus 10 minus 8. So I will have, this will give me 23 minus X. So there you have express F. So F is by itself in terms of X. And there your answer has X in it. So that's the answer there, 10.3. 10.3 says, if E is 17 minus X. So if E is 17 minus X, so this E is 17 minus X. Calculate or determine the numerical value of X. So let's quickly look. So we know F plus 10 plus 8 plus X plus 8 plus 13 plus 9 plus E plus this 9 outside. All of these numbers, they must give me a total of 84. So I'm going to write that down. So I'm going to write at the bottom F plus X plus 8 plus 10 plus 9 plus 13 plus E plus the 9 outside must give me a total of 84 learners. Okay? But now you have an expression for F. F is 23 minus X. So I'm going to replace F with 23 minus X. So plus X plus 8 plus 8 plus 10 plus 9 plus 13 plus E, but E, I have an expression for E. In the information, it said E is 17 minus X. So plus 17 minus X plus 9 is equal to 84. Okay, so now we're just going to add our like terms. So let's underline. There's an X, there's an X, and there's an X. Okay? If you add that up, you get negative X is equal to. Then you have 84 minus 9 minus 17 minus minus. So, okay, let's write that down. 84 minus 23 minus 8 minus 10 minus 9, 13, 17 minus another 9. So, negative X is equal to, I get this to be minus 5. So, then I just divide both sides by negative 1 to get a positive X, and I get this to be positive 5. So, X is positive 5. This is question 10 from a different question paper. It says events A and B are independent. Okay, so the events are definitely independent. And P of A is 0,6 and P of B is 0,5. Okay, then the question is, are the events mutually exclusive? Motivate your answer. So for events to be mutually exclusive, let's write this down. For events to be mutually exclusive, P of A and B must be 0. So we have to prove that this is true. So let's see if we can prove that this is true. So let's just put this in a box so you see, you have to prove this. But because the events are independent, so it says here the events are independent. When events are independent, then P of A times P of B is exactly the same as P of A and B. So this is definitely true. So this is true because the events are independent. So to work out P of A and B, to work that out, I'm simply going to say, what's P of A? 0,6. And what is P of B? 0,5. And I'm going to multiply those two. And I get that answer to be 0,3. So P of A and B is 0,3. So can you see that we try to prove this, but it's not the case. So here we say that therefore, our events are not mutually exclusive. So you can say here, because P of A and B, so P of A and B is not equal to 0. It's equal to 0,3. And that's how you would do a question like that. Okay, next is 10.1.2, and here it says, represent the information in a Venn diagram. Okay, so let's do our Venn diagram. We have two events, so two circles. They have an intersection, so they will have this part over here because the events are not mutually exclusive. So this will be event A, this will be event B. So this part over here is PA and B. So probability of PA and B. So in the previous question, we worked out PA and B. It was 0,3. So that part goes there. Then this whole circle is P of A. That whole circle is P of A. And in the information, it says P of A is 0,6. So that means this number is 0,6, the whole circle, minus this part, minus that 0,3. And that gives me 0,3 for that part. Then this part over here, you can work out by saying this whole P of B. So P of B is 0,5. So 0,5 minus this part, because it's still part of BA, take it out and I get 0,2. Okay, so now for our last part, the outside part, we know that this plus this plus this plus the outside must give me 1. So I'm going to say 1 minus 0,3 minus the other 0,3 minus that will give me the outside, and that is 0,2. So here on the outside, I will write 0,2. Okay, let's mark this. So for this A and B, that's a mark. For these two, for both of them, that's a mark. Both of them must be right, and then for the outside. And that's why this is 3 marks. Okay, our next question, 10.1.3 says, calculate the probability of A only. So this is A, but only this part is A only. So you can answer that question just by looking at your Venn diagram. P of A only is 0,3. Remember, that's already probability, So it's 0,3. Then the next question, so this was A. B, probability of not A or not B. So I'm going to make a tick by not A. So let me take another color and not A. So this is not A. So that is not A. And that is also not A. Then I'm going to make a tick by not B. So this is not B. And this is not B. So now I'm going to look which of my numbers has 2 ticks. But remember, these red ticks, they don't count, because this was just marking the previous question. Every number that has a tick, I'm going to add. So 0,2 has a tick. Although it has 2 ticks, I just write it down once. Then 0,3 has a tick. 0,2 has a tick. I add them all up and I get 0,7. And that's how you do that one. Okay, now we're going to 10.2. Okay, 10.2 says, the contingency table below represents 100 learners' responses regarding camping. So you have boys, there's the total boys, girls, there's the total girls, and you have those who like camping, there's the total for the people who like camping. They dislike camping, that's their total. And this total is this plus this, or it's this plus that. That's how you get that total. So 10.2.1 says, if a learner from this group is chosen randomly, what is the probability that it is a girl? So 10.2.1 is, what is the probability that the learner is a girl? So I'm going to look at my total number of girls, that's 62. And write that over the total number of learners, that's 100. And I get that answer to be 0,62. Okay, next question. Is the event like camping independent of gender? So for events to be independent, P of A times P of B must be exactly the same as P of A and B. Okay, so I have to prove this. I have to prove that the left-hand side is equal to the right-hand side. Okay, let's make notes. P of A is anyone who likes camping. B is gender. So now it's either you use boys or you use girls. So I think I'm going to use boys. So you can also use girls. So I'm going to use like camping and boys. So then this is also like camping. And this is now boys. Okay, so let's see. What is the probability of liking camping? Leave the boys or the girls out of this now. Just P of A. The probability of liking camping. Okay, if you like camping, what's the probability? So I'm going to go to like camping and I'm looking at the total. Just like that. It's 54 over the total number of learners. Times. What's the probability of being a boy? So not a boy who likes camping or a boy who dislikes camping. Just a boy. The probability of being a boy is the total number of boys over the total number of learners. So total number of boys, total number of learners. And I get that answer to be 0,2025. Okay, so that's my left-hand side. Let's look at the right-hand side. P of A and B. So now I'm going to look for like camping and a boy. So it must be boys who like camping. So boys who like camping, there it is 24 over 100. So this is 24 over the total number of learners. And this gives me 0,24. So can you see this is the right hand side? So I can see that the left hand side is not equal to the right-hand side. So if they are not equal, then we can say the events are not independent. And that's how you would do that question. So you do a left hand and a right hand.